Hey everybody, so for my Choice 1 project, I decided to do a screencast thematic, which is basically just a video of my screen of Geometry Sketchpad and a lesson I could give to it. Geometry Sketchpad is basically an interactive geometry software. It's mostly used for geometry, but it also could be used to explore algebra, calculus, and a lot of other classes that I've actually done this in. More or less, this is just kind of a world where you could just kind of play around. You could put some dots in, you could put some lines, you could switch it up and make a ray, you could make a line, and even cooler, you can make lots of circles with a radius, whatever you want. So, as you can see, this could be pretty useful in the geometry world. And today, what I'm actually going to walk you through is a lesson in regular shapes and how you can construct them and what their definitions are. And I'm just going to do four. As you can see on the bottom here, we have an equilateral triangle, a square, a rhombus, and a regular hexagon. So to start, we're going to do an equilateral triangle, and we're going to start with the definition. Geometry Sketchpad also lets you type, which is kind of a good thing. So an equilateral triangle, not triangle, triangle, if I could spell, I'm a math major, is a regular triangle. Now, that may seem redundant, but what does it mean? Regular means that all sides are the same length. So, now it comes to the point, how do we construct this thing? Well, we start off with two circles. Any radius you want. You pick this point, and you come back at it with another circle. Now, what we just did is we made sure that both of these circles have the same radius. So we drop a point and its intersection point, and by connecting these 3 points, we actually have an equilateral triangle. Now the coolest thing in my idea about Geometry Sketchpad is that after you're done constructing, these things are very solid, as in you could drag a point, move it around, you got a lot of equilateral triangles all around. Looking good. You could do this for days. I have, don't worry. Also, gives you the option of making things a little bit more clear. If I wanted to show you exactly what shape I was talking about, I could highlight it for you. That way, all these things could go away and I could actually make the circles faded, but I won't waste your time there. Okay, so that's an equilateral triangle. We can move on to the, oh actually another thing I wanted to do is if you wanted, because I said that equilateral triangle is a regular triangle, and now I told you that these are all the same radius of two different circles. But to actually check, you know, to take my word for it, you can actually measure and go to lengths, and sure enough, we see that every single side is 5.01 centimeters. And as I move it, they move the same. So now that's an equilateral triangle, and we will move on to the square. Okay, so now a square, definition-wise, you may all know this, but some people take this differently. A square is a rhombus with a right angle. Now you might say, oh, doesn't it need 4 right angles? Doesn't it need, you know, all the same sides? Well, a rhombus means all 4 same sides. We'll go over that in the next one. And it's actually proven that if you have all right angles, or one right angle, then all right angles if it's a regular polygon, which we will talk about another day, another time. So to construct a square, it's going to be a little more difficult than the equilateral triangle, but we're going to start the same way. We're going to start with our 2 circles with the same radius. And by radius, just in case some of you have forgotten, I just mean the length from here to here, from the middle of the circle out to the side. And since these guys both have the same radius, it's very useful. What we'll do now is we'll drop a perpendicular bisector by making this line and this line. If you forget what that means, it means that this line bisects this line, and this also makes right angles at this point and at this point. Now, you may say, why would you do such a thing? Well, if we actually make a circle centered there outward, and we connect these 4 points in a second, believe it or not, you end up with an awesome square. Now, like I said before, one of my favorite parts when I get done, just to make check, grab a point, have some fun, see what happens. As you can see, our square is staying square, which is always a good thing. Now, I want to check yet again. I wonder if all these sides are the same. They should be, right? It's a square. We're going to go up to measure lengths. Well, what do you know? They are all the same. And even more, you might say, okay, well, how do you know it's a right angle? Well, let's check it out. We go up to measure. We can actually measure the angle. Well, look at that. It is a 90-degree angle. That is exactly what I wanted to see. And later on in geometry classes, you'll actually learn that because these 2 points are on the diameter, that since it's an angle, it makes an angle on the diameter, then you know that this is 90. But again, another day, another class. So that was the square. Next we will move on to the rhombus. So definition-wise, as we started off the last coup, a rhombus is a regular quadrilateral. Now, regular we talked about before. All it means that it has the same lengths of the sides, and quadrilateral, for most of you who know this, if not, it's just a shape with 4 sides. So, to construct, like all the rest of them, we're going to start off exactly the same. We have a circle, we have another circle. Now, from here, we want to actually find, so right now we have this side right here. We want 4 more just like it, because we want a 4-sided shape that are all the sides are the same lengths. Well, if we take another circle, because circles are the bomb, and we start it anywhere on this circle and drag it in towards this point, we now have 1 more point that is the same as this. These 2 are the same because it's the 2 radii of the same circle. Likewise, if we make a point here, then we have, it's fair to say that all 3 of these circles have the same radii since we made them from using their radii. So if we bring all these points together, we begin to see something that looks like a shape. I'll outline it for you, you can't see it. It's a nice lime green. Oh, that didn't work out. We'll do it one more time. Sometimes geometry Sketchpad can be a little fun sometimes. But anyway, so now we have this shape. And like always, I like to take it and I like to see what we can do with it. So as you can see, this thing kind of just slides around. Sometimes geometry Sketchpad freezes out because of the fact that I don't have more circles. But you get the gist. So we'll do our regular checks. We grab all of our sides. We say, okay, this should be the same. Let's check it out. Well, indeed it is. And it should be, because all these circles have the same radii because we made it so. So therefore all of our sides should be the same. Awesome. So, moving on. Next. So this one should be fun. As you all know, a hexagon is a shape with 6 sides, but a regular hexagon, like we've said before, is a regular, and I'm sure you are all screaming at the computer being like, I know, but math is fun, so here we go. Is a hexagon with equal sides. And I should say lengths would probably be a better word, but anyway. So to make this, we're going to guess with, what do you know, a circle. I know you guys are so excited about circles. So you have that. So I bet now you're wondering, well, okay, so we have that. What else do we do? Well, very good question. We have to get some equal sides like the rest of them. So we're actually going to start at this point, well, at this point. That sounded redundant. We're going to make a line in. Now you may say, okay, why did you just do that? Well, if we actually see this point here and this point here, these 2 are the same. These 2 have circles of the same radii. We made it that way. Well, from this point to this point is the same distance as from this point to this point. So we're on our way. If you see what I'm talking about here. So now it's just a little bit of fun. We just continue along the circle. We say, okay, from here to here, from here to here, from here to here, and last but not least, from here to here. We take our segment maker and go along the initial circle. We can see that we're building the coolest of cool regular hexagons. And I'm definitely going to shade this one in because it gets a little weird. So as you can see, using these are all circles of the same radii, so all of the radii have to be the same because we made it that way. So therefore, and I'm going to check it for you, we highlight all these sides, measure the lengths, should be that way. We get all of them the same, which is nice. And again, we can grab any point. Well, maybe not any point. Let's see here. Here we go. We can twist this thing around like it's cool. Well, it is cool. Anyway, so yeah, so I hope you learned a little bit about Geometry Sketchpad and the awesome works it could do. I hope you learned a little bit about regular shapes and how awesome they are. And I hope that at some point in the future you think of Geometry Sketchpad if you ever need anything to do with anything math and technology. It really is a helpful tool. And if you have any questions, I'm always here. Thanks for watching. Have a good one.